Hello, thank you for listening to us today. We are Group 1 and our group members are Dana Zamorano, Laura Tobar, Miriam Aguilera, Medhat Elawani, Tania Limon, and Nubia Puga. Today we're going to be talking to you about the integration, verification, validation, and test plan of a concession stand system. As we all have been to the movies, we have either have a really exciting experience or a really bad experience whenever we go and order our food, which can be really exciting to a lot of people to be able to have their popcorns within the movies to have a better experience. We have either had the experience where the queues are really long that we have to lose time of the movie, or sometimes once we get to the front of the line, the products we want are not in the inventory, not giving us the best experience to have. Therefore, we have created this plan to be able to deliver in time, quality, and form the final product to the clients. Within our presentation, we're going to be talking about different subjects, including the introduction, where we're going to talk about the purpose, system overview, the points of contacts. We will also be sharing the reference documents, the key terms and definitions, the organization and management, risk management, the BBT evaluation activities, and the actual activities performed, as well as a conclusion and a discussion from our part. We would like to start off by presenting the introduction of the objective of this project. As previously mentioned, the struggle is real within the concession stands of moving theaters, as we always need to take into consideration that the customer satisfaction is the most important part of a system. Therefore, the objective of this BBT plan is to have an efficient process where the waiting times in the queue lines are not that long, allowing the customers to have an incredible satisfaction within the system and their experience. And in order to be able to fulfill this, we have created a list of activities and documents and projects that need to be fulfilled in order for us to have that final output. We're going to be taking into consideration some key elements for optimization, which are the hardware dependencies, especially the ones that have to do with the payment methods. Also, we're going to be talking about some improvement opportunities within the system in order to reduce the waiting times, and all of this will be focused especially during the peak hours in order to analyze and make sure that the system will always be working as intended. Here we have created an outline about how the system looks using the FlexSim software. And as you can see, the main point of entrance, we have the reception where the clients will be entering the system, and there are different waiting lines in which they can take part of. There is some waiting area rooms, and also there's a queue line from which a client can choose whether to pay in the kiosk payment or pay directly to the employees, asking for the final product to be delivered, which is manufactured in the back. Now that we have seen how the general outline looks, we want to introduce to you the system overview. Basically, the heart of the cinema experience, it has the objective for the customers to have a great experience that they want to go back there again, allowing the owner to have an increase within the money being generated. We have noticed that there are some challenges which are regarding the extended waiting times, and this might be due to sometimes malfunctioning of hardware equipment, which we will be taking into consideration for this project. We have the BBT plan driving operational excellence. We're going to be making sure that within our plan, our main objective is to always have the optimal process, analyzing any potential risks and failures that the system might present in order for us to present a solution and take action rather than having to stop the system and solve the problem at that time. We will also make sure the hardware presence assurance is working as intended within all the subsystems, and at the end of the day, this will allow us to have an efficient queuing and high quality service so that our customers are always having a constant flow within the system. Here at the bottom, you can see we have the general process overview where the customers enters the queue. The server takes the order. Once they have taken the order, the software has an inventory update. Within this inventory update, we will be working with the Oracle system, which will be creating the connection between the payment, the registration of the inventory, and making all the count of the items that we currently have. The order will be taking into the system will check if we have the inventory available for the order. The order will then be processed for the payment to be processed, the inventory will be updated, and the final product will be delivered to the client. If at any point you have any questions regarding this project, you can always reach out to any of the team members, in which here you can see the points of contacts and the scheduling hours during which time you can reach out to any of us.
In order to provide transparency, credibility, and a comprehensive understanding of our project, we have listed the documents that we use throughout the journey of the conception of this project and the completion of it. As you can see here, we have a list of the project references, which is a CMMI development, verification and validation and testing of engineered systems by Angle, the Inclusi Handbook, and the FPMA Insights in Manufacturing Industry. The documents related to this project cover various aspects of the project, including its inception, planning, design, development, testing, and evaluation. So each document was carefully crafted to offer insights into our specific phases, providing a high-level overview and detailed information where necessary. So here you can find a list of the documents related to this project and the standard procedures that were used.
In this slide, we have the key terms and definitions. On the left side, we have the term, and on the right side, we have the definition, such as CONOPS, that is the concept of operation, and the definition will be a review of the system intended use. We have a list that we will be using throughout the document to specify or recall any document that we've used or term needed. In this slide, we have the acronyms. On the left side, we have the acronym, and on the right side, we have the definition. In here, we have included a list of acronyms that we will be using throughout the document, so the audience may refer back to this slide.
The successful development of the VVT plan depends on several factors. Among them, organization and management play an important role. In our project, the team organization is shown in the following organization chart. The team leader assumes accountability for overseeing and directing V&V activities, ensuring tasks are allocated and executed effectively within the concession stand. The project manager oversees the entire project, including the V&V effort within the concession stand, setting objectives, distributing resources, and coordinating V&V tasks within the overall project plan. The process manager, in collaboration with the team leader, focuses on refining and optimizing V&V processes, ensuring well-defined tasks aligned with industry best practices. The quality manager is responsible for maintaining and verifying V&V quality. The VVT planner outlines how V&V processes seamlessly integrate into other critical processes, providing a comprehensive approach specifically designed for the development. The lines that connect the different roles indicate the direct collaboration that exists between one position and another. Organization and management also includes the planning of the project, which is reflected in the master schedule shown in this slide. Here, we can find the different activities to be carried out in order to execute the plan, as well as their status, start date, and duration. The main activities of this project are VVT definition phase, design phase, implementation phase, integration phase, qualification and acceptance phase, analysis, documentation, review, and approval.
So in the risk matrix, we see the risk assessments, how they're conducted and how they're evaluated and the probability of the potential impact of various scenarios with specific applications. So um, crucial factors influencing risks around the unpredictable and undesirable of events. The risk model employs evaluations that determine the likelihood of a risk factor occurring, utilizing different diverse approaches tailored to the category specifically being examined and listed on here. So to gauge the impact effectively, the assessment involves measuring specific events associated with the risk. So by employing quantifiable matrix, we can gain a nuanced understanding of the potential consequences. So this is where we see the matrix and the measurability of the risk. So on the left you see the risk options, which is listed in 3 different sections, which is in green accept, yellow mitigation, red mitigation and contingency. The risk table below is a comprehensive risk management approach for the concession stand. So our strategy involved in identifying and assessing strategically mitigating potential risks that could impact the operation, from operational challenges to financial uncertainties. And identifying these potential risks, this includes everything from day-to-day operational challenges to broader financial safety, regulatory, or technical issues. And as you can see here, we use to measure these. We use the matrix list that was discussed before this slide. The risks that we see listed here in this table include everything from day-to-day operational challenges to broader financial or even regulatory concerns. So these risks sometimes can stem from something internal or external. So it's something that will help us prioritize the efforts to assess the impact of each of these identified risks, and that could be most significantly impactful to the concession stand. So the heart of the risk management lies in our mitigation strategies and carefully crafting plans to tackle these potential problems.
The Requirement Verification Matrix (RVM) works to determine the method that should be used to verify each requirement of the system, the time when this method should be performed, and the necessary procedures for that method. Some key elements of the RVM are requirement identification code, requirement traceability to other documents, verification methods, verification stage, and procedure identification code. All RVM should include these elements. In the image on the left, we may see the identification codes that were used in the table at the right for the concession stand system RVM.
The following method was followed to generate and update the traceability matrix. All system requirements were listed on the x-axis where each column represented a requirement, and all subsystems and elements were listed on the y-axis where each row represented one element. For forward traceability was started by tracking each requirement and seeking the relationship with all the elements. If there is a relation, then this should be reflected in the intersecting cell by using an asterisk. FMEA is an acronym for Failure Mode Effect Analysis. It is a verification technique used in systems engineering to estimate for potential problems. This means that it is worthwhile to estimate the degree of failures and their impact beforehand. The most important failure mode effect analysis terms are failure cause, failure mode, failure effect, and failure severity. The failure cause underlying causes which may cause a process to fail. The failure mode is the cause of how a system or a process may fail, which reviews the way a system is being used and the results of the failure in it. The failure effect identifies the immediate results in in the failure in a function or functionality. Failure severity finds the consequences of a failure mode by identifying what is the worst outcome of that type of failure by degree of injury, property, and or system damage. For the types of failure mode effect analysis, they are four types: the design, functional, system, and process FMEA. The design FMEA, this process is implemented during the design phase of a system. It allows to determine how failure modes affect the system operation. For the functional FMEA, analysis potential problems and loss of functionality, the estimation of the probability of problem and the potential damage in order to expedite the implementation solutions to the issue. For the system FMEA, it analyzes a system more in detail, looking at each component of the system to understand how a failure will affect individual parts and its interactions. Finally, for the process FMEA, the procedure that is mainly implemented on manufacturing process. This process identifies limitations of resources, equipment, tooling, gauges, operator training, or other sources of errors. Thank you.
For this slide, we have the defect removal process. We have 6 points, where the first one is to first identify any defect, and in here it will be by doing continuous monitoring and user feedbacks to detect the defects within various stages of the system. The second one is to issue tracking. In here, this system is used within the team members to report any defects and track information and document details. So for the peer reviews, a regular peer review system must be conducted by establishing and discussing clear review processes using checklists and predefined criteria for criteria components. Then the fourth one is the root cause analysis. By conducting this, it's to understand why defects occur and implement corrective and preventive actions to address these underlying causes. Then the fifth one is to perform verification and validation. By doing these activities, the system ensures that all the defects are identified and successfully resolved, fulfilling the quality standards. Lastly, it's the walkthrough and internal audits. In here, this system has to be done every 6 months to confirm the functionality and identify any areas of improvement. The next thing on our BVT activity list is to have a checklist, where the objective of having a checklist is to make sure that the concession stand is tested for defects and issues, improving the overall quality and reliability of the system. And the objective of the project is to verify that the concession stand meets all the specifically functional requirements. The requirements that have to be tested, it's first of all to ensure that the system accurately processes and records sales transactions, such as how precise it's saving all the data, as well as marking the data for inventory. It also has to confirm that the menu items and prices are correctly displayed on updates. So if an item has changed the price or is out of stock, for it to be displayed. To test system performance during peak hours to ensure it can handle high traffic. So when there's peak hours, the system has to ensure that it's capable of meeting the needs, and if not, to see what needs to be improved. Then to verify that the system scales gracefully without performance degradation. Due to the selling of candy or more granular options, there has to be scales, and they have to be working correctly and properly, as well as having a user interface so all the information is kept, and having hardware components such as a computer, a printer, and more, a payment processing. So to have either cash payments or with card payments, as well as security. And this can convey part of the security as a security person or security for the hardware and software. So it's well maintained and it's secure for the customer to be using their credit or debit card. The compliance and regulations that it's to keep everything under control, and error handling, recovery, and backup to see when, if an error happens, how is it solved, how it can be recovered, or if there's any backup for if any information is deleted by mistake, as well as a user training for an employee to be able to use all these, all the equipment that it's provided to them, documentation and manuals to have everything in order, customer satisfaction for the customer to keep coming to the concession stand, as well as having a satisfactory visit, and a defect log summary to have all the defects that had happened before and how they were solved. So if it happens in the future, they have something to look for. The
As we have talked in the previous slides, we have noticed that keeping track of documentation is crucial when it comes to BBT activities. Therefore, when we identify any type of defect or risk within the system, we need to record these type of situations. That's why we have come up with a layout as to how a defect log needs to be recorded for a specific system. This is the template that we have proposed, which we indicate the project name, the version they created, and the last day updated. We assign the defect ID so that we can keep track of each one of those. Then we have to describe the type of defect we have found, categorize it if it's really dangerous or hazardous. At that moment, we know that we have to take activity, or maybe it's not that dangerous and the action can be taken later. Then you also describe the priority, if you're gonna, which type of rework you're gonna do, or maybe the defect can be ignored at that moment and be prolonged later, and who's gonna be doing this rework, and so on and so on. This will help to maintain track and be able to analyze any type of trend that's identified within the system in order to be able to identify what's hurting the most our concession stand, to be able to rework any type of defect and prevent any future risks from happening. Now that we have seen which activities need to be taken into consideration for our BBT to be optimal, we will now talk about the actual process we have followed with this BBT. Starting off with the definition phase, which consists of 6 different parts, which is the BBT generation, the review support, concept phase, concept of operations, system requirements, and actually generating the RBM. So to start off, we will be talking about the generation of the master plan, in which the main input is that we will be taking into consideration the scope of the concession stand requirements, and within that those requirements we can actually elaborate all the plan to be followed in order for us to have the output, which is the final revised master plan of the BBT. We will also be taking into consideration the software requirements, which are the Microsoft projects, and within this case we will also be taking into consideration the Oracle software, and we will have a schedule with concurrent follow-ups for us to be able to deliver the project in time and form. Additionally, within the personnel requirements, we will be working with different functions such as the planning manager, the staff members, team leader, and quality managers to be able to use all of these assets within different activities and have an optimal final product. Now, let's talk about the review support. We will have continuous review and follow-up sessions in which we will have different activities performed. To start off the session, we have a first review to analyze where we're currently at, and then we will move on to analyze all the open actions and adjustments that we need to be taking into consideration, dividing these activities to different responsible people. Finally, once we have completed the session, we will create a publication and agreement of engagement to be able to keep up with the systems. Within these sessions, we will also have brainstorming and asking questions in order to have all the insight needed to continue with the project. Moving on to the concepts phase and the concept of operations review, we would like to start off with the phrase we have come up with, which is the concession stand, where entertainment meets satisfaction. Optimizing our system ensures an exceptional cinema experience for our valued customers. We want to emphasize on this part as our customer is the main objective of this project. We always want to make sure that the final outcome is for our customers to have a great experience within the system. And in order to perform that, we have the concept phase, which we have analyzed all the system and subsystems that are important within the project to be able to identify where the system is being hurt and work from there to improve those cases. We also analyze the operational description of a use case, and we have worked with defect logs and checklists which have allowed us to keep with the documentation and track as to which processes we need to follow. Additionally, we have traceability and operational requirements, which have allowed us to have the connection between the system and the client to have the optimal final outcome. In here, we can see a use case diagram we have created where we talk about the interaction between the system and the user, the concession worker, and the administrator. Within the user or customer, we can see that they have different interactions depending as to, starting off with the lineup, they can make the decision of the order they want to make, either which food they want to have or which drinks they want to have. They can review the order, and then at the end they pay for the final order. Then we have the interaction within that concession worker and the system, which they have to make sure that the order is accurate and the final product is delivered as intended. Also, they have to make sure that the process has been paid as intended and update any order status if required. Then we have the other view of the system, which is from the part of the administrators, where they're going to be managing the new items needed to be updated in the menu, or on the other hand, which items need to be deleted. They will also be checking the transactions within the Oracle systems, making sure that the prices are also being updated as intended. And with this, they will be allowed to analyze the demand and any trends needed in order to change or decrease or increase any inventory if needed. And they will be continuously checking the quality of the products and the service that we're currently offering to the clients.
In system requirements definition, the primary objective is to precisely articulate the system's mission, ensuring a seamless traceability to the user needs. So this document outlined a comprehensive set of requirements encompassing the both qualitative and quantitative constraints. So these requirements can span from various categories, including functional, external interfaces, performance, design constraints, and quality attributes. So on the list, we see several of them, which is the system boundary, system environment, system functions, system constraints, system data, system states, system error conditions, and hardware interfaces. So these served as a guiding document throughout the development process to ensure that the final system aligned precisely with what the user expected in the operational needs. So the inclusion of both of these qualitative and quantitative constraints provided a well-rounded framework to develop and promoting clarity and consistency throughout the project and its delivery. In the definition phase of the RVM, we see a breakdown of the system and how it's thoroughly analyzed, and this includes understanding the documents and the documenting the functional and non-functional requirements. So here we see a list of the other requirements, and it's divided in sections. And the ones that we can appreciate here is performance and communication. And the task at hand here in this section is to generate and update the requirement verification matrix at completion of each life cycle to review the traceability and verify the specific requirements methods the team lead selected, and the review activity allocated in the phase where it should be. So it will be a review and update of the document. scheduling and personal requirement. So this is what we see here, and the the requirements and the listing of everything that was reviewed and projected.
The BBT activities and the definition phase, we included a table with each requirement number, the category, because we have different categories such as performance, communication, and equipment, with an ID number where we define the requirement, such as the system shall be able to process orders in the established cycle time, that it's less than 4 minutes with an average orders. Large orders may be analyzed apart in a table so we can refer back to this, and also to identify the first requirement in what category it is and what does it entails. In this slide, we have more regarding the equipment category as well as the safety and compliance category, with each requirement ID, the category it is, and the requirement specification. For the design phase, we need to look out for several main points, such as gather information of each subsystem, such as the time it takes, how it performs, and then analyze the data collected, so to interpret the results, then present the results such as graphs and analysis, then identify the bottlenecks and improvement opportunities, especially during peak hours, and agree on improvements that must be made, such as upgrades and or feedback. In After this, we have to generate an action list to reach those improvements, so having a goal list, then assign responsible and due dates for, as employee responsibilities, and assign follow-up meetings and schedule to review all the changes to see if they were effective or any other change has to be implemented. In the design phase, we have to do a task that will be validate the system design tool. How are we going to be doing this? By a review assessment. So our output will be the system design checklist and the system design defect log that will be used where the system's requirement were none, and the schedule that we've included is that it has to be first initiated on September 25th of 2023. That prototype checklist should be done on September 29th of 2023, and the personal reviews should be also done by October 2, 2023. After this, we have personal requirements that include the process and quality managers to have a prototype checklist and project defect log documents. The BBT team members will be using this operation description checklist and the SIS requirement to conduct personal review, and then after that, the team will hold a peer review and fill the project defect log.
Now for the details for the design phase, we're focusing on generating and updating the requirement by directionality traceability matrix. The primary task is to generate and update the RBTM at the end of each life cycle. We're all about maintaining that traceability. The method involves verifying design cases traceability by connecting them to the system requirements through a document to use cases RBTM. We've got a systematic approach here. We list all system requirements, each subsystem, and elements. We use an asterisk for forward traceability, indicating relationships between requirements and elements. If there's no intersection, it could mean a redundant requirement or a missing element. For backward traceability, we start with the elements and check corresponding requirements, using slashes to indicate relations. If there's no intersection, it could mean the element is redundant. The VVT team will trace assigned requirements and use cases while the quality manager will verify and comply matrices. All personnel involved must have the necessary training and all documentation must be in the latest revision. Now we're diving into the design phase for assessing failure mode effect analysis for our concession stand project. Our task is to identify potential failure modes. Essentially, what could go wrong with our concession stand? We're looking at causes, effects, the frequency of failures, and their impact on the system, all aimed at minimizing future issues. The FMEA is a process where we scrutinize potential failures in both technical and management processes. We've got a concession stand system design team assessing failure modes, causes, effects, severity and frequency and impact. The idea is to take corrective actions based on the priority of the risks. We've got some key metrics. Severity is crucial. Think electrical power outages or hardware downtime. Occurrence is about the frequency of failure, which we're mitigating with preventive maintenance. Detection is interesting. The concession stand doesn't auto-detect failures. The lane controller has to monitor sensor events. And overall, the priority is based on preventing or reducing system failures. After the assessments, we'll have designed FMEA severity, occurrence, and detection evaluations. The concession stand system support process and quality managers are heading up the FMEA preparation. Our VVT members will oversee severity, occurrence, detection, and compute all those important risk priority numbers.
We present here the cost-benefit analysis, the CBA. The purpose of using the CPA technique is to calculate the benefits and costs using a number of parameters which are risk identification, probability of occurrence, and severity of the risk. The technique requires expertise in identifying the risks, then calculations to arrive at a more accurate estimation. For the method used to develop the CBA, we did the following. First, we determined the probability of failure, which is for that requirement, we chose 10 will be a very high probability, while 1 is a very low probability. For the severity, a disaster severity would be 10, while 1 would be a minor severity. The total probability is the multiplication of probability of failure by the severity. The VVT cost, which is the cost of verification, validation, and testing, is the cost of performing the tests required to confirm integrity and reliability. This VVT cost must be related to what is mentioned already in the requirement. For example, if we say that the hardware will not exceed $60,000, then VVT for sure must be a ratio of that. Let's say 10 or 20%. The appraisal cost is the cost of rework based on the probability of finding faults in the system after performing the VVT tests. The appraisal cost is typically a fraction of the VVT cost. The impact cost is the cost of impact caused by not testing the VVT at all. Impact cost examples would be loss of human life, insurance cost, and other liability costs. The total cost is the sum of VVT cost plus appraisal cost plus impact cost.
Implementation phase. In this phase, the subsystems will be tested and put into work so the VVT team will be able to debug the complete system. The final delivery of this phase will be to give measurable results of the system performance with qualitative and quantitative data to compare it against the design. Documentation during this phase is crucial to create standards and procedures that will be later followed up to meet the objective of the concession stand. The processes that should be followed for this phase are component tests, where the performance of each component will be analyzed as well as its interaction with other components to determine if it's complying with the system established goal. System test documentation evaluation. Here, we must ensure that all test documentation correctly reflects the implementation requirements. Test case description should include component, integration, system, and acceptance test cases. Finally, test execution and reports refers to the analysis of the results to determine that the component correctly implements design. And all this should be captured in a report.
Now let's delve into the integration phase for our concession stand project. In this phase, we're putting our concession stand to work with comprehensive tests over a set period in varying hours. The goal is to evaluate how the components integrate, their performance, and how they align with the system's objectives. The VMP planner takes the lead here. They're setting the schedule for our required tests, ensuring we have the right tools and resources. The management team is fully supporting to make sure everything is in place for these tests. The deliverables include a comprehensive integration test plan, generation of integration test procedures, the actual performance of integration testing following those procedures, an analysis of the integration test results, and recommendations for the next step. The process looks like this. We will have the component test, the test case description, and the test execution and reports. Our next section is the qualification and acceptance phase for our concession stand project. After conducting all of our tests, we present the results to the management team. If adjustments are needed, those recommendations are laid out as well. For each test, the status is clearly defined as yes if it meets acceptance criteria, under revision if it needs further review, or rejected if it doesn't meet specifications. Clear and straightforward. The final deliverable is a comprehensive report summarizing all tests. It includes a final decision for each component, whether it's accepted or not, and how it interacts with the other system components. We also provide a list of recommendations in case any elements are out of specifications. We maintain clarity. The analysis of results is straightforward with an acceptance, under revision, or rejected. We make sure that the final decision for each component is clearly stated along with its causes. The recommendation list are there to guide us in any necessary adjustments.
In conclusion, the verification and validation testing process has been instrumental in assuring the successful optimization of our concession stand project that has been done through meticulous testing, analyzing, and validation. And this system has confirmed to fully met the specified requirements, positioning it for a seamless transition to release and production. This comprehensive VBT effort have provided a true assessment of the system functionality, performance, and reliability as detailed in the documentation. The results offer compelling evidence of the system preparedness to meet the needs and expectations of our stakeholders. The VBT process has played a crucial role in identifying and rectifying potential issues, enhancing the system robustness, and ultimately certifying its fitness for deployment. This through verification and validation process underscores the commitment to deliver a high quality and reliable concession system in line with the project goals. The success of the VBT process is not only contributed to the robustness of the team, but also the efficacy of collaborative teamwork and adept project management, a dedicated team that comprised skills individuals for various disciplines that display a pivotal role in ensuring the seamless execution of the IVVT activity, as well as the collaborative efforts in task allocation and execution. Thank you. Please let us know if you have any questions and feel free to reach out to any of us.